Welcome to the computer class. Today we are going to continue chapter 8 methods. The objectives of my today's topic are you will learn pure and impure functions, call by value and call by reference, and the use of keyword static. First of all, we will start with call by value and call by reference. So please open your books at page number 193. First of all, we will discuss some key terms. Number 1, call by value. The process in which changes in the arguments are not reflected back in the original values. Means actual parameters and formal parameters remain different. Number 2, call by reference. Functions which change the values of arguments sent to it. Means in this, changes made in actual arguments are reflected in the formal parameters. Next term is pure function. Functions which do not change the state of an object. Impure function. Functions which change the state of an object. Static members. The members of the class that are not meant to be accessible to the objects of the class. Means objects that we make in the class do not access the members that are static. Non-static members. The members of the class that are meant to be accessible to the objects of the class. Now we will discuss each of the concept in detail with different points and examples. Our first topic is pass by value, also known as call by values. Student, we can pass values to the methods in two ways. Number 1, pass by value. Number 2, pass by reference, also known as call by reference. Pass by value works on primitive data types like char, int, byte, short, long, float, tuple, and boolean. The called method creates its own copy of the argument values and uses them. Any changes made in the formal parameter values does not reflect in the actual parameters. Thus, actual parameter values remain unchanged. Means the values that we pass in the calling function remains unchanged. Whereas in pass by reference, it works on reference data types like objects or arrays. The called method does not create its own copy of the argument values. Any changes made in the formal parameters are reflected in the actual parameters. Thus, the actual parameter values are also changed. Now, we are going to discuss it with the help of a BlueJ program. Now, here in BlueJ, I am going to create a program by creating a class named as CBV, call by value. Now, in this class, I am going to create two methods. First, I will create a class, public class CBV. Then in this class, I am going to declare a variable named num. Then I am going to create a function public void compute. And in that, I am going to declare a local variable that is n. Now, I will n equals to n multiplied by 2. Means I am going to perform any operation on n, and then I am going to print the value of n. And this is value in method call. And here I am going to pass n. In this way I have created a method public void compute. Now I am going to create a second method public void test, in which I am not passing any of the parameters. Then here I will declare an integer called num, with that I give the value 5. Now I will print the value of num. Println, then because here I am not going to apply any operation to num till now, so its original value is num semicolon. Now I am going to call the method compute, and in bracket I am going to pass the value num. Num means this number 5. And now I will write down system.out.println value after method call is plus num. Now that was the value before method call, and this is the value after method call. Now in this way I have created my program. Now I am going to compile my program. Compile, minimize it. Now right click on the program and create its object with the help of new CBV. The object name is CBV1. Okay. Now here right click on the object and call the function void test, because in test function we have called the another function, that is compute. Now you can see the original value is 5, because this was the value that we have declared in test function. Value in the method call, that is 10, because 5 2s are 10. But this changed value is not reflected after method call. After method call, value remains 5 only. So this is call by value. In call by value, the changes in this method call are not reflected in this formal parameters. Now we are going to do call by reference. For call by reference, I am going to make the changes in the same program. Here I have done CBR. Now here I am going to create an object of the class CBR OB. Why OB? Because OB is the object of CBR. In call by reference or pass by reference, we used to pass the non-primitive data type. Now here I will write OB dot num is equals to OB dot num multiplied by 2, and here I am going to display OB dot num. OB is the object of CBR class. Now here again I have created an object of the class, that is CBR obj is equals to new CBR. Now I am going to use this object obj to declare my variable num, which is equals to 5. Then I am going to print the message over here, system.out.println, then original value, then close it, plus sign, and here I will write down obj dot num. Clear? We have used the second object over here, that is obj dot num. Now I am going to call the function compute, and in bracket I am going to pass again the second variable object obj. Okay, and now close it. Then again I am going to print the result system.out.println value after method call, and then close it, and here I am again going to call obj.now. So you can see over here that here I have created two objects. One, this object that is within this function only, that is compute, and one obj object that is in the function test, and in that function also I have called the other method that is compute. Now I am going to compile this program. Class compile, no syntax. Minimize the screen, right click on it, create an object cbr1. Now right click over here and call the method test. Now you can see original value, that is 5, and value in the method call is 10, and value after the method call is 10. The changes are reflected back from the original data and means actual data, and they are in the formal parameter. So this is passed by reference, in which any changes made to the value of the formal parameters means this, they get reflected back in the actual parameters. This is the actual parameter obj, but its value is 10 after the method call. Now students, come to page number 96 of your books. Pure and impure methods. Pure methods does not change the original state of an object. Always returns the same value when the same arguments are given. Students, call by value can be an example of pure method. Number 2, impure methods change the original state of an object. Every time it is called, it does not return the same value when the same arguments are given. So, call by reference can be the example of impure method. Students, important thing to notice that the string objects are immutable in Java, which means they cannot be changed once they are created. Even if the strings are passed by reference, they cannot be changed. Why? Because the strings are neither primitive nor reference data types in Java. They are specific data types in Java. Now, our next topic is static and non-static methods at page number 98. Static methods. Its return syntax is public static return type, method name, parameter list, and method body. Non-static methods. Public return type, method name, parameter list, method body. Means in static methods we will make the use of static keyword, and in non-static method we will not use the static keyword. Now we are going to discuss these two kind of methods with the help of a Bugy program. For showing you the difference between static and non-static method, I have created a class named demo class over here, in which I have declared a function cube as static, and its return type is int, in which I have taken the parameter int y. Now I am going to calculate the result. Result equals to y into y into y, and return the result. Next function I have created, that is cube for making the difference from first function, and this is the non-static function because here I have not used the keyword static. In it I have passed one argument, that is x. Then int result equals to x into x into x, and then return result. Now students, in main method I have taken two variables int a comma p, and I have created an object of demo class, that is OB. Now in a variable I am going to call the non-static function, that is CUUB, with the value 4. And in b variable I have called the static function, that is CUBQ. Students, you can note over here that while calling a non-static method, I have made the use of this object of the class. And while calling the static method, I have directly used the class name. Its another example is like you use math class in your Java program, math.sqrt. So you are calling sqrt function directly with the help of the class name, that is math. So that sqrt function is a static method. Now we are going to show its result. Minimize it, right click, void main. So here the output is non-static method, that is 64, static method, that is 64. The answer is same, but the difference lies in the way of calling the function. Non-static methods are called by the object of the class, whereas static methods are called by the class name. So students, today we have learned call by value, call by reference, pure methods, impure methods, static methods and non-static methods. Do practice all these programs on UJ. Thank you.